Okay, so let's continue on with the development of this solution. So the problem solver. So we've developed the element class, okay, and we also developed a very simple main class to test that the element class actually worked. So just to reiterate what we've done, so we've developed the element class and we've commented the code beautifully. It's got variable names that reflect what the variables hold. And you'll notice from what we originally designed to what we actually implemented, we made a slight variation. So originally we had 3 fields, a type, a value, and a unit, and we decided to drop the unit field because we didn't really need it. We could just simply generate the unit inside the getUnit method. So because we changed the design when we implemented it, we have to go back to the design and actually change it. So let's just grab that line and delete it. It's gone. All right, so it's always very important to ensure that your design, reflects what it is you've actually done. Okay, so technically when I thought, oh, we don't need that unit field anymore, I should have come back to the design, actually looked at it and thought, what is the consequences of removing it? But I sort of, when I implemented it, I kind of realized what the consequences were, that it was very minor and actually produced slightly better code. So it was actually worthwhile doing that. Okay, so we've developed this little bit down here, the element class, and now we need to start looking at how we're going to implement the problem class. Okay, so the responsibility of the problem class is to pass a string that we give it, and the string will effectively represent one of those lines of text, which is the problem, and it's supposed to pass that string looking in. So when you create a problem object, it's supposed to pass that string, look for the 2 elements inside there, and create element objects based on those 2 bits. So let's have a look. So what I'm going to do is I'm going to start writing this, and then we might look at one I've done prior. Okay, so we're going to start developing this. So it's public class problem. All right, so we didn't have any fields in there. We have a LE being referred to. So that's the other thing, as I originally said that I was going to have. So it's going to be private. This is going to have LE1, LE2. So I can have LE1 and LE2 if I really wanted to, but it's probably easier to make it an array. Okay, so I've got an array of elements, and I'm going to call it LE. All right. Okay, so what does my constructor need to do? So my constructor, so public problem, and it's going to take a string, which is going to be the description. So remember that Java is case sensitive, so that has to be capital S. Right, so I'm just going to take the description. Okay, and what I'm going to do in here now is I effectively need to create that array. So I'm going to go LE equals new element. Okay, so basically I was going to create an array where each element is an element object, and I'm going to make it size 2. Okay, so there's my my array of 2 elements created. It hasn't actually created the objects themselves, it's just created the space for the 2 objects to actually sit. Alright, so now what I need to do is I'm going to use a scanner. So I need a scanner. And that scanner is going to pass through the string that I've submitted. So it's going to pass through disk, and it's going to look for those particular elements inside there. So because I'm using a scanner, I'm going to need to import java.util.scanner. Okay, so now I want to go through that string word at a time. So I'm going to do a while loop. So while has next, so while there is a word, I'm going to keep scanning through that. So I need to, so has next is the method, but I need to put the reference in front of that because this is a dynamic class. So while there is a word available, we want to keep scanning through that string, looking for the location of where the things that, where the words with equal signs actually are. So while sc.hasNext, so while there's a word, we keep scanning through the sentence until we find a particular word that has an equals in it. So obviously what I need to do is I actually need to get a word. We might even call it word. Okay, so it'll be sc.next, okay, to grab that particular word. And then what we're going to do is we're going to check if if word dot index of, and we're looking for the equal sign, is greater than or equal to 0. So if it is greater, so if it's so if we get back index of the equals being greater than or equal to 0, then that means we have actually found a word that contains an equals. Alright, so therefore when we find that, we can say, hey, let's create my element. Okay, so obviously I'm going to need a variable here called index, which I'm going to post increment. So after I've put LE at that index location, I'm actually going to then increment it. And so we want to create a new element, and we want to pass in the word into the constructor. Okay, it might help if I spell it right, but we'll pass the word in, and that's it. Bob's your uncle. We've now created that. So like I said, we need to initialize a int called index. Well, we need to put that at the first location. Okay, so therefore there's only going to be 2 words in that sentence that actually have an equals in it. So therefore at the end of this, we would have only created 2 elements. So those 2 elements will in fact be created as a result of the constructor. So the constructor will actually create those 2 elements and have them nicely ready to go for our solve method. Okay, so here we'll have public solve, and it returns an element. Okay, it's called solve, doesn't have any arguments, and what it's actually going to do is it's actually going to solve the problems for us. So what it's going to do is it's going to look into both of those 2 elements, and it's going to find what type they are. Okay, and if element 1 was a power and element 2 was a voltage, then that means we have to find the current. Okay, and so depending on what the type of those 2 elements are, we're going to find something. So this solve method is effectively just going to be a whole heap of if this. So if element 1 is this and element 2 is this, then we're going to do this. Else, if element 1 is this and element 2 is this, we're going to do that. So it's going to be a whole heap of if then else statements with a bit of maths, and once we've calculated our bit of maths, we're going to create an element object, and that's what we're going to return from this method. Okay.